Hello, good morning. So today's class is about hydroboration and its applications. As you know, hydroboration is the addition of boron to carbon-carbon multiple bonds. So hydroboration, as we have already known this, hydroboration is the addition of boron of boron to the carbon-carbon multiple bonds. Carbon-carbon multiple bonds. Okay, so you can just say this is a carbon-carbon double bond reacts with boron. Boron exists as a diboron. Okay, so dicline, in presence of dicline, so you can have this type of BH3 like this. Okay, addition of boron step place. So here boron exists as diboron, as a dimer. Okay, as diboron, which uh, which can be which 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 can be easily dissociated, easily dissociates as, okay, like this. Okay, you can write the structure of boron like this. This is a diboron. This is diboron. Okay, so this can go dissociate in this way to keep this to over here hydrogen. Okay, so you can have two one like this. This is sp2 structure is sp2 planar form, sp2 planar, and this is trigonal. Okay, trigonal sp2 hybridized. So this is the B2H3 diboron. Can we have BH3 boron? Okay, this is like this. So actual addition takes place by boron. So addition of, I'm repeating again, hydroboration is the addition of boron to the carbon-carbon multiple bonds. So I'm giving just some example here. C with boron reacts with to get this one. So here addition takes place. You guys know hydrogen addition takes place. Hydrogen addition takes place to the less substituted carbon atom of the double bond to give the more substituted boron. Okay, I'm giving one example here. Say RCH double bond CH2. So here boron attack. So hydrogen attack to the less substituted carbon atom to give this one R CH2 CH2 B H2. Okay, so here actually like this you can have, it's coming from diboron to boron. So here it takes this substitute carbon atom to give this like this. So here another molecule can attack, this one can attack by another molecule of alkene olefinic compounds. So you can have another one R CH2 CH2 B. Okay, these two molecules like this. So here hydrogen decreases, number of hydrogen atoms, and 3 to like this. Again you can another olefinic compound can attack also here to give CH2 CH2. So it comes here 3. Okay, so you can have here first one is monoalkyl boron. First one is monoalkyl boron. This one is monoalkyl boron. This is dialkyl boron, and third one is trialkyl boron. Okay, so one molecule of boron can react with 3 molecules of olefinic compounds to give trialkyl boron. So here addition takes place in a antimarconical sulfide. So hydrogen attacks the less substituted hydrogen atom. So hydrogen atom attacks to the less substituted carbon atom to give more substituted alkyl boron. Okay, alkyl boron, and that means the boron is linked with the more substituted carbon atom. So here I'm giving about the hydroboration, how it takes place. So you can 3 molecules of like this boron can react with 3 molecules of olefinic compounds to give the alkyl boron. So this alkyl products you can undergo further reactions. These alkyl boron products can undergo further reactions to give many other types of reactions. Okay, so alkyl borons I have written here. Alkyl boron products can undergo further or can undergo many types of reactions. So like this oxidation and hydrolysis. Hydrolysis we also say protonolysis. We can say it's similar with protonolysis. Addition of proton hydrolysis and carbonylation like this carbonylation, etc. Okay, so alkyl boron product we obtain by reaction of hydroboration product. So reaction with boron reaction with alkenes can undergo further reactions. So first is, let's say one by one. So oxidation of alkyl boron product. So let's, for example, I'm giving general examples. Okay, yeah, general example is alkene reacts with boron pH 3. So we got 3 molecules. Will give 3 molecules. So we have RCH2, CH2, get 3 B. Okay, so we got this alkyl boron. So it is not isolated. So this can this is alkyl boron, alkyl substituted boron. So these are product of hydroboration reactions. Reaction with this boron with olefinic compound. So we got this trialkyl boron. So this when you react with this sodium hydroxide in presence of hydrogen peroxide, in presence of sodium hydroxide, oxidation takes place. So this will give alcohol. So 3 molecules of CH2 OH takes place. Okay, plus B OH3 like this. So reaction mechanism I'll show the reaction mechanism how oxidation of this oxidation product gives alcohol. So oxidation of alkyl boron undergo oxidation with hydrogen peroxide in presence of sodium hydroxide to give alcohol. So I'll give the example mechanism here. So first is let's say this trialkyl boron. Okay, we have this 3 CH2 R. Okay, so here also CH2 R. Here also CH2 R. So here we have 3 alkyl substituted trialkyl boron is obtained by hydroboration of this alkene with boron. Okay, so this is one reacts with hydrogen peroxide. So hydrogen peroxide reacts. So hydrogen peroxide H2O2 in presence of sodium hydroxide. So this will give hydrogen peroxide will attack like this OH. So by sodium hydroxide will give this one. So water. So attacks These two reactions will get this one. So this is attack here. So here, so let us write this R prime. Okay, all this R prime here also R prime. Then you can have CH2 R. Okay, then is we have O OH. Okay, now this is negative charge here. So this charge is given to here boron. So now migration takes place this way. Okay, so like this. So you can have R prime. So this R prime is all this group. Okay. The another one is this group. Okay, we have two groups of here R prime here. So now we have this O negative charge plus now link up with this one. So ISO CH2 R. So we got alcohol. So like this, if you use more hydrogen, this will be replaced. So you can get, so it can undergo further reactions. So you can have hydrogen peroxide, instead of hydroxide. So you can get more molecules of three molecules. You can get all these are substituted. So you get 3 molecules of R, CH2OH. Okay, and finally this will be replaced by OH3, hydroxyboron. Okay, so this is the mechanism of oxidation reaction of trialkyl boron by using hydrogen peroxide in presence of sodium hydroxide. So I'm repeating again. So this peroxide attacks the boron, so it becomes negative charge. Then migration takes place. So you give like this. Then pick up the proton. So it comes. So you can take proceed. Similarly, you can have sequence can be 2 by twice. Okay. Then final product will be 3 molecules of alcohol, like, and then final product will be like this. So this is about the oxidation of hydroboration products with hydrogen peroxide and sodium oxide. Now let's come to second one. Second reaction is hydrolysis, that is protonolysis. So we can, second one is hydrolysis. Hydrolysis, or we can say protonolysis. That is addition of protonolysis. So here also same case, alkyl borans obtained from hydroboration of alkenes can undergo hydrolysis with acidization takes place, catalyzed by acid. So mostly acetic acid or benzoic acid. So let's say I write down here. So let's say this common reaction. So this is alkene. So first is hydroboration takes place with boron. Okay, these 3 boron takes place. So you can have trialkyl boron. So first is trialkyl boron is formed. Is all same. Okay. So this trialkyl boron can undergo hydrolysis in presence of acid. So let's say R prime COOH. So acid hydrolysis takes place. So this will give protonylation takes place. So it will give additional protons. So CH2, CH3 like this. So to come 3 molecules like this. Okay. So I write the mechanism how it goes. So additional protons here takes place. So additional proton, this is why it is called protonolysis. So let's see the mechanism of the formation of this compound. So first mechanism. Okay. Mechanism is first one we got this trialkyl boron hydroboration reaction. So here hydrogen attacks the less carbon atom to give more substituted like this. So we got R, CH2, okay, B. Okay, here also let's say CH2, R. Okay, so 3 molecules are here. So we have CH2, R. Okay, so this is one trialkyl boron. So in presence of acids, so let's say acids OOH. Okay, reacts with this one acids. So first attacks this will come. This acid will attack here. So first will formation of this. Let's write this on R prime. Okay, boron R prime. This is R prime. So we represent this R prime. So we have the double prime. Okay, acids. So first we have this CH2, CH2R, then this is linked with oxygen, then double bond CR double prime here. Okay, the double prime, you can see double prime here. Then we have OH here, OH. Okay, so now it become positive charge here. So we got a sec this intermediate fast formation. So you take here, we can attack the boron, so won't become negative charge here. Now pick up the proton here. So you pick up the proton. So here protonizes it. Proton is pick up to get this one. Okay, like this. So we got this product. So B R R R prime. So you have O C O R double prime. Okay. So first step is this one. Then you got CH3 H3C CH2R. So additional proton takes place. So now you can use more molecule. So more three further undergo further reactions with these acids. Then you got 3 molecules of this alkane. So from alkane to alkane, we get like this by protonolysis, hydrolysis in presence of acids. So this is about the I'm repeating again. So hydroboration product. This hydroboration product by reaction of alkane with morane can undergo further reactions with acids to give the protonolysis product or hydrolysis product. So it undergoes acid hydration product. So this is the mechanism. First step is attack here, then negative charge here, then pick up the proton, then we'll go like this. So you got this one. So we can undergo further reactions. So finally we get 3 molecules of this alkane. So this is about the hydrolysis of alkyl borane. Okay, now the third one is carbonylation, reaction with carbon monoxide. So alkyl borane can undergo reaction with third one is carbonylation. Okay, so you can say reaction with carbon monoxide. Okay, so here I just similarly like article 1. This one, the alkane reacts with borane. So we got trialkyl borane. Okay, first is alkyl borane. Alkyl borane is obtained. This alkyl borane can undergo reaction with carbon monoxide. Carbon monoxide can be present like this. So attacks here borane. So you can write this way: R CH2 B, or you can write, let's say this 2R, these are, you can say like earlier one, R prime. So here, so this carbon, then oxygen. So here positive charge. So now this comes negative charge. So addition takes place. First step is carbon monoxide attack to the trialkyl borane to get this one. This R prime is this groups. Okay, I'm just representing. So now migration takes place. These groups migrate like this. So this gives R CH2 now C double bond O, then boron, then R prime. Okay, so reaction like this. So product is this one. So this product intermediate can react with lithium hydrido aluminum, this OR prime. Okay, say O methoxyco. Okay, you can say lithium hydrido trimethoxy aluminate. You can write lithium hydrido. This is a complex. Okay, hydrido hydride. Okay, hydrido trimethoxy aluminate. Okay, so yeah, this is reducing agent like lithium hydride. So all the 3 hydrogen atoms are replaced by methoxy group. So there is only hydrogen atom. So this is hydride transfer takes from here, like earlier cases. So it takes here hydride from here, it takes here, so like this. So it can hydrolysis, then we'll give one intermediate we get here RCH2, CH2, CH, OH, then more than like this. Okay, so we got this intermediate. Okay, when this reacts, this compound reacts with lithium hydrido trimethoxyaluminate, we got this type of compound. And this one, when you oxidize with hydrogen peroxide, unlike earlier one, in presence of sodium hydroxide, the alkali, then we got this alcohol. Okay, CH2, CH2, CH2OH. I think you can see this one. Okay, I'll just acting here. So finally this one, oxidation of this will give RCH2, CH2, CH2OH, alcohol. So I'm repeating again this mechanism as well as reactions. So first is hydroboration product to form this trialkyl borane by reacting this alkene with borane to get the trialkyl borane. This trialkyl borane can undergo carbonylation by reacting with carbon monoxide. So carbon monoxide attack with the boron. So you got this negative charge here, then you got here. Then migration takes place to give this carbon groups. Then hydride lithium hydrido trimethoxyaluminate. So hydride transfer takes place. So then hydrolysis will get this product, and finally this oxidation with hydrogen peroxide in presence of sodium hydroxide alkali, we got this alcohol. Okay, so these are about the hydroboration in each applications. So we got under hydroboration products can undergo oxidation, hydrolysis, photolysis, and carbonylation. So we can have 3 types of reactions. Okay. Now another similarly we have another alkyl borane. We can have discuss this one in relation to this one. So we have 9 BBN, very 9 BBN. So another hydroboration product. Okay. So here 9 BBN is can be obtained by reacting with 1,5-cyclooctadiene, 1,5 you can say cyclo octa 1,5-diene. When reacted with 9 BBN can be obtained by reacting with this 8 member ring. Okay, cyclooctadiene reacting with borane in pH shape at 0 degrees Celsius. So we got a very bright color compound. So this we got this. So reacting as so these diene are here. So you can attack this one B, attack with B, and this one. This one. B is here. Okay. So actually we use this one, not cyclic one. 1, 5, 1, 2, 1, 2, 3, 4, 5. Okay. So when you have this borane, here borane hydrogen here, this BH3. So one can attack here, so you can have another can attack here like this, 2 molecules. So first step will be formation of this one. So like okay, 1, 2, 3, 4, 5, 6. So here BH2. First will be BH2. Okay, this boron attack here. 1, 2, 3, 4, 5. Okay, 1, 5. This is not cyclooctadiene. This is 1, 5 dienes. 1, 5 diene reacts with borane. I'm just giving one example. So you give first one. So this I can attack this one. So you can attack this one. Okay. So you can have another. I don't know this one. Attack here. This more saturated carbon to give this one. Okay. So here also like this. Here more to give this one. So mechanism like this. So we got further reaction takes place. So we got a cyclic sub member in here. B ice. Okay, so 1,5-dienes reacts with boron to get this product. Similarly, when you react with cyclooctadiene, 1,5-cyclooctadiene, this cyclic compounds, then we got this product. So this is, so I'm giving here reaction mechanism just like this. So addition takes place, hydride transfer to the hydrogen transfer to the more substituted carbon atom to give this one, and then again the another two are here. So again I take to give this one like this. So this is the product. So similarly, I can attack like this one. So to give this cyclooctadiene reacts with boron to give this 9 BBN. So 9 BBN is actually name is, so here 9. So you can get 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 bora. Oh, this is two cyclic compounds. Bora bicyclo. This is 1, 2, 3. Okay, 3. Then here is 1, 2, 3, 3, 3, and this one is 1. 9 bora, 9 atoms are here. 9 bora bicyclo, non-end. Okay, so this is called 9 BBN. You can say 9 BBN. 9 bora bicyclo, non-end. So the actual name is, so here I'm giving again here boron here 9 positions and bicyclic compounds. So 1, 2, 3 is 3. Here's 1, 2, 3 here, and 1 here. So it is called 9 bora bicyclo, non-end. This is very useful for for reactions with many reactions with hydroboration reactions, then undergo alkylborations, oxidation, then earlier cases. So here we can represent this simply. We can present this way. 9 BBN we can present this way. No, I will write simply. Okay, this one present this one by BN appears here, and this one. Okay, like this. This one. So 1, 2, 3. See one. This is link. Okay, 1, 2, 3. Here also 1 here. 1, 2, 3, and then this is red and brown. Okay, this is this one here, and this 1, 2, 3. 1, 2, 3. Here also 1, 1, 2, 3. Okay, you can. So 1, 2, 3, 4, 5, 6, 7, 8, 9, like this. Okay, so you can present this in 9 BB another form, or you can write simply. You can write this way. So this is the way you can represent like this. So this is 9 BBN can use for many reactions like earlier cases. So you can like boron you can attack with a reduction take place. So I write one by one 9 reactions of 9 BBN. So first one is reductions with 9 BBN. So 9 BBN can react with any alkenes like earlier cases. So hydroboration takes place. CH2, so 9 BBN. 9 BBN is, so we can write this way. Okay, 9 BBN. So here the hydrogen transferred to the less substituted more substituted carbon atom to give this compound. Okay, so first product is alkenes react with 9 BBN to get the alkyl boron. This alkyl boron is CH2, CH2, B, like this. So these alkyl borons is very reactive, can undergo many types of reactions. So it can undergo many types of reactions like cases, oxidation, then protonolysis, then carbonolysis, like this. So this is a alkyl boron product of from the obtained by reaction of alkene with 9 BBN. So this is the way. So we can use this one for say oxidation, the earlier cases oxidation. So first this reaction with alkyl borons undergo. Okay, this boron reaction with alkyl boron react with by obtained by aliphatic compound, alkenes with boron non-BBN. So they can undergo the reaction with hydrogen peroxide in presence of sodium dioxide. So it can be obtained as in earlier cases similar mechanisms. So you can have alcohol, okay, CH2 alcohol. So my mechanism is simply mechanism the earlier one. So hydrogen peroxide reacts with sodium dioxide, got this anion oxide attack here. So this will give first step is RCH2, CH2, B negative charge here. So here OH, okay. Then migration takes place like earlier cases. So here like this. So negative charge here. So it just gives R, CH2, CH2, OH, alcohol, then B, OH, okay, OH, after hydrolysis, B boron like this, okay. Okay, pick up the proton here. So in presence of proton, like this. So it got alcohol and then this product, okay. So this is the way for getting this oxidation reaction, like similar like boron reacts with alkyl boron reacts with other cases. So non-BBN can undergo oxidation product with alkyl boron can undergo non-BBN alkyl boron can undergo further reaction to get this alcohol. So next step is about protonolysis. So I'll show the protonolysis. So non-BBN, second one is protonolysis or hydrolysis or protonolysis. Protonolysis. Okay. So it is a reaction with acids here. So first, let's say linear reactions is alkene. So the first hydroborations with 9-BBN. 9-BBN hydroboration takes place. 9-BBN. Then we got this alkyl boron. This alkyl boron. Okay, this alkyl boron products, hydroboration product. Alkyl boron product. So this like the earlier case hydrogen attack here and like this. Okay, this can undergo reaction with acids are fine COOH. So this will give first will give R CH2 CH3. Okay, so like this. So then the alkane to alkane is formed. This is alkane. Addition of proton takes place. So the mechanism will same like earlier cases, like so alkyl borons first reacts with acids. First reacts with acids. So here attacks here. So you got mechanical reaction is like this. CH2, CH2, B. Okay. Then here oxygen double bond C and OH. This OH, then this R prime. Okay, this is acid part. Now this positive charge, this negative charge. Okay, so attack here like this. So this again undergo this pick up the proton here. So pick up the proton and like this. So you got R CH2 CH3 in alkane of 10 plus. You got this boron R prime here, C double bond O, then B like this. Okay, this is the product. So this is the protonolysis. So this alkyl boron obtained from reaction of alkene with an BBN can also undergo protonolysis to give this alkane. Okay, so this is about the protonolysis. Now third one is reaction is carbonylation. Okay, carbonylation. Here undergo reaction with this like earlier cases. This one I'm giving this one. You have many alkene you can use Okay, so you will 9 BBN, 9 BBN. So you can have reaction can take place RCH2, CH2, so like this. Okay, so we got alkyl boron. So first reaction with carbon monoxide. So reaction with carbon monoxide, this is carbon monoxide. So I take here boron. So we got R, CH2, CH2, B, so like this. Okay, then here carbon, then oxygen, positive charge here. So here negative charge here. Then migration takes place. This group migrated to here R, CH2, CH2, so here carbon, then this BBN part here. Okay, so you got this password. Then the earlier one reacts with reduction with lithium hydrido trimethoxy aluminate. Lithium hydrido trimethoxy aluminate. So reduce this one first. This is reduced to CaOH. Then this one. Okay, got this one. Then if you react, this is reaction with hydrogen peroxide in presence of sodium hydroxide, alkali. Then you got this product will be this alcohol. Okay, CH2, CH2OH. So we got this carbonylation product. So the reaction of alkyl boron obtained from hydroboration with alkene and BBN will give this reaction with the carbon monoxide will give this product. Okay, so we got alcohol. So it can be modified if you this one, if you use this one, these reactions, so react with lithium aluminum hydride. So this product use lithium aluminum hydride to undergo further reactions. So I write down here. Okay, this one. So I write down here. Reaction of this. Now first this with carbon monoxide. Okay, then second one is with lithium hydrido trimethoxy aluminate, then followed by lithium aluminum hydride, and finally reaction with hydrogen peroxide will give this aldehyde. Okay, CH2, CH2, CHO. So this one you can try this one. Okay, so CH2, CHO. So aldehyde obtained. So these are the obtained product. So final reaction with finally this carbon, this alkyl boron from 9BN can be obtained by reaction with alpha halo ketones. Okay, reaction with alpha halo carbonyl compounds. So like many alpha halo carbonyl compounds like alpha halo carbonyl compounds are like alpha halo ketones, alpha halo ethers, alpha halo esters like this. So I'm here 9BBN alkyl boron obtained from 9BBN can react with the like the alpha bromoacetate, or you can say another one alpha bromoacetate, or you can over frame ester type. Okay, this reaction will give in presence of base will give R CH2, the R come here and C double bond O or prime. So reaction takes place. Alpha halo carbonyl compounds or ester, alpha halo ketones, alpha halo esters can react with alkyl boron obtained from 9BN reaction with alkene to get this compound. So I'll give one example here. Say the earlier cases. CH2 reacts with 9BBN. So you got RCH2, CH2, Okay, like this. Okay, this one. Then you react with the potassium tertiary butoxide, potassium tertiary butoxide. You can write Bu, potassium tertiary butoxide, negative charge, butoxide. So you CH3 or CH3 groups, and you can get product this one. And reacts with another compound CO2 R prime or ether ester. You can get the final product will be R CH2 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 CO2 So this one you can get this one. Okay, so one example I'm giving. So here reaction mechanism is like this. I will show the mechanism here. First step is reaction with this reaction with, we got this compound. Okay, this one got this compound. Reaction with first step is the alpha bromoacetate, the bromine CH2 CO2 in presence of base potassium tertiary butoxide, potassium tertiary butoxide. Okay, after the proton from here, we got this one, PRC is carbon ion is formed, CO2 So this carbon ion attack this one with this alkyl boron obtained from RCH2 CH2 this one RCH2 RCH double bond as a CH2 reacts with non-BBN, obtain this one RCH2 CH2. There is some problem in the last part, so I'm repeating again. Okay, this one due to some problem. Anyway, so first I'm repeating again. So we got the alkene with a non-BBN, we got a alkyl boron, then reacts with this this bromoacetate, anion forms, then they take it here. First we got this one product. Okay, then this migration takes place from here, so like this migration takes place. So we got a product RCH2 CH2 CH, so we have bromide is lost. Okay, CH CO2 then the boron. Okay, so here, then this final this with alkoxide group. So you cannot see here, I'm just writing here. This one non-BBN. Okay, here BB. Okay, so this one after reaction with base again, so this will again take up. I take here OR negative charge. So I take here, so it will give like this. Pick up the proton. So final product will be RCH2, CH2, and CH2, CO2. Okay, so this is the final product. So I'm repeating again. So yeah, 9 BBN alkyl boron obtained from reacting with alkene. 9 BBN will get alkyl boron. The alkyl boron can live with alpha hydrocarbonic compounds. So here alpha hydroester to a bromoester. It reacts with ethyl bromoacetate. It reacts with the strong base like potassium tertiary butoxide. You got carbon ion, then carbon ion attack with this alkyl boron. You got negative charge here, and migration takes place. Bromide loss, so we got intermediate, and it's finally reacts with the alkoxide group, and then protonation. We got a final product. So this is the mechanism for reaction with alpha hydrocarbon compound with alkyl boron. So this is about this hydroboration and application today. So I wind up here for today. Okay.